For today's lesson, we are going to look at a series. Given that the first series converge and the answer equals to log 2. All the terms in the first and second series are exactly the same, it's just that the orders are different. So what will be the value for the second series? Please give it a try before look at the answer.
Pause the video now if you wish to solve it. Keep watching the video once ready.
Before we discuss the answer for today's question, let us look at the series. This is so-called alternating harmonic series. If we look at this, it actually makes sense because we start from 1. So for the first term, we get the value 1. And for the second term, we subtract half of it, so we get this term. After which, we add 1/3. This is a half, so 1/3 is about here. So we get this value. After which, we subtract from here 1/4. This is 1/4, so we get this value. After that, we add 1/5, so 1/5. After that, we go back 1/6, and so on and so forth, and we should have each converge to some point here. Using mathematics, we can find out that this value is log 2. Why is it log 2? We define fx as such, and we can see that f prime x will be equals to 1 minus x plus x squared minus x cubed plus x4, and so on and so forth. And we can see that this is actually equals to -1 to the power n, x to the power n. And we can recognize that this series is actually a geometric series with the first term 1 and the common ratio of -x. So the sum will be equals to a over 1 minus r. R equals to -1. So this is 1 over 1 plus x. Since f prime equals to 1 over 1 plus x, and therefore fx will be integration of that, and it will be equals to log of 1 plus x plus c. Now note that when x equals to 0, f0 is equals to 0. C is equals to 0. So we will say that fx is equals to log of 1 plus x. We need to also take note that f prime is equals to 1 over 1 plus x if the model of x is less than 1. Since we already showed that this series is convergent, then we can say that when x equals to 1, it should have some value, and this value, it will be equals to a log 2 when you sub in 1 here. So this is the way to prove that this is equals to log 2. For this question, 1 minus half minus 1 over 4 plus 1 over 3 minus 1 over 6 minus 1 over 8 plus 1 over 5 minus 1 over 10 minus 1 over 12. This is 2k minus 1, 4k minus 2 minus 4k. Note that the commutative law does not obey if you have infinite many of them. That is, in general, a plus b equals to b plus a. This is true if you have finitely many of them. So for simple calculation, we will see that this is equals to a half minus 1 over 4 plus 1 over 6 minus 1 over 8 plus 1 over 10 minus 1 over 12. And for this, this is 1 over 4k minus 2 minus 1 over 4k, and so on and so forth. The denominator for each of the term is an even number, so we can take out the half, and this is equal to 1 minus 1 over 2 plus 1 over 3 minus 1 over 4 plus 1 over 5 minus 1 over 6, and plus 1 over 2k minus 1 minus 1 over 2k and so on and so forth. And this is exactly what you have just now, and therefore this is half of log 2. And half log 2 is about 0.3466. We want to see whether this answer makes sense to us. So we start from 1 and minus 1 over 2 and minus 1 over 4. Negative 1 over 2 minus 1 over 4 is less than negative 1 over 2 minus 1 over 2, which is less than 1. So it will be less than 1, and supposedly it comes to here. This is negative 1 over 2 minus 1 over 4. You add 1 over 3. So 1 over 3 is less than 1 over 2, so it will be still within here, 1 over 3. And these two terms, negative 1 over 6 minus 1 over 8 is less than negative 1 over 6 minus 1 over 6, and this is negative 1 over 3, is still within this range, that is 1 over 3. And the process will go on 1 over 5, and it eventually will reach somewhere here. From the answer, this is half of log 2. From the alternating harmonic series, we can rearrange the term and get something that less than the original answer. It is also possible for you to rearrange so that you can get answer that bigger than log 2. An example as shown. Next, this is possibly another extension from this alternating harmonic series. That is, the first term is getting from log 2 minus the first term here. And this is a negative value. And the second term, it is log 2 minus the first two terms of the original series. And you can see that this is a positive value. Next, the log 2 minus the first three terms of the original series, and so on and so forth. Are you able to get what is the sum that it converges to? If you do, please comment to me. This is the end of the video. Hope you enjoyed it. See you next week.